Hello everyone, I'm Swapnil Baparanetke. Currently, I'm doing Masters in Pharmaceutics Department at Pune College of Pharmacy, Pune. Today, I'm going to deliver you the demonstration on electrospinning equipment, which is a very cost-effective method for production of nanofiber batches. The equipment is used in our institute is manufactured by Geonics in Systec. Before proceeding for the demonstration, I would like to give you some basic information regarding the electrospinning technique, like its principle, mechanism, and also the parameters which will affect the electrospinning process.
So firstly, we will see what is meant by electrospinning. It is a technique which uses electric forces to draw a charged thread of polymer solution up to a fiber diameter in order to some micro ranges. If we split the word electrospinning, that is electro and spinning, ultimately we will give its mechanism. Uh, that is first is high volt means electro, and the second is spinning of polymer, that is spinning. So the basic principle behind the electrospinning is the strong mutual repulsive forces overcomes weaker forces of the surface tension in charged polymer solution. We will see in detail of this working in the next slide. So the instrumentation and the working mechanism of electrospinning. In the instrumentation of electrospinning, four main components are present. That is a syringe, a pump, the electric supply, and collector. So the working process of the electrospinning is when the process starts, the solution is ejected from the nozzle of the syringe by the pump. Then the droplet is subjected to a high voltage, and the difference in electric voltage present between the nozzle and the collector with the counter charge, and the resultant electric voltage causes a cone-shaped deformation of the droplet known as Taylor cone. When the voltage suppresses the threshold value, that is critical voltage, the electric forces overcomes the surface tension of the droplet, and the charge jet solution is ejected from the needle of the syringe. So we will get the nanofibers. Next is types of electrospinning system. Electrospinning system is mainly of two types, horizontal and vertical. In our lab, we are using the vertical type electrospinning system, which will give a thinner fiber diameter, wide diameter distribution of fibers, and the horizontal type of system gives you thicker fiber diameter and then narrower diameter distribution of the fibers. As we can see both in the diagram. Factors affecting electrospinning. Mainly two factors are affecting the electrospin, that is the solution parameter and the process parameter. It will affect the fiber morphology and the fiber diameter. The solution parameter is that the viscosity, conductivity, molecular weight, and the surface tension. And the process parameters are the electric field, tip to collector distance, the flow rate, the hydrostatic pressure, the humidity, and the temperature. These both parameters will be optimized on the lab scale. As we are taking several batches for it to optimize the parameters. Then we will move on for the next slide. Applications for electrospinning technique is the biomedicine, drug delivery, wound healing, protective clothing, filtration, energy generation, and the scaffolding tissue engineering. The several advantages and the applications will be obtained from the electrospinning technique. Then what is meant by nanofibers? Nanofibers are fibers with a diameter in the nanometer range, that is 1 to 100 nanometers. It can be generated from different polymers like natural and synthetic origin. The chitosan, chitin, and the fibrogen are some of the example of natural polymer. Then the PVA, PVC, and PVP are the example of synthetic polymer. Then next is the characteristics of the nanofibers. The high surface area, pyramid mass, high porosity, lightweight, tunable pore size, flexibility in surface functionalities, relatively good mechanical strength, and the high permeability are the characteristics for the nanofibers. Different type of instruments used in the characterization of nanofibers, that is same time, and then the Fourier transfer infrared spectroscopy, TGA and the DSC, and also the X-ray diffraction. The same is analysis is used for determine the morphology and the diameter of fiber. Then the FTIR used to determine the chemical changes, and the TG and DSCs will be used to determine the thermal transition and the temperature. And X-ray diffraction is we used to calculate the crystallinity and the amorphous region of the fibers. So next we will be move on the demonstration part. Thank you.
Hello everyone, I am from Department of Pharmaceutics. So this is the equipment called Electro Spinning. So I am giving a demonstration on this. In this demonstration we will see the actual working, assembly and the controller for the mechanical parameters which we will set for obtaining nanofibers. So basically the mechanical parameters are set for optimized batch which will be carried out on electro spinning. These parameters are set by taking several batches. So we will see the controllers. Here is the main switch which is used for power and off and on the main system. Then here is the switches for fan, cabinet light and the backlight. Then the syringe pump which is usually controlling the flow rate of the system. This flow rate is usually 0.2 to 0.4. It is all depends upon the nature of the polymers, as it is natural or synthetic. Then the drum controller, drum controller which is usually used for controlling the RPM of the drum. It is usually between the range of 200 to 300. It depends upon the also the nature of the polymer. Then the high voltage. The high voltage controller which is used for controlling the voltage of the system. It is usually 0 to 15 kilovolts. So it is very dangerous. Take proper precautions for that. Use of latex rubber hand gloves and wear shoes before handling the instruments. So we will further proceed for the assembly. Here we can see the door of the chamber. It is denoting that it is dangerous, high voltage. So it is quite risky due to high voltage to open the door during the operation. So take proper precautions. As soon as when you open the door, discharge the system using the Isha stick and then move for further process.
Let's see the assembly. It is vertical type of arrangement. This is collector and this is the pump. You can see two pumps are given over here. As the distance between them is usually 10 to 20 centimeter, as it affects the morphology of the nanofibers. This is a wooden tray in which syringe is kept inside this hole. This is nozzle in which needle is kept or entrapped. Here you can see the negative end is connected to the drum collector and the positive end is connected to the nozzle. So let's see how it is actually be working. As you can see the arrangement, the syringe is filled with the polymeric solution and the drum collector is wrapped with aluminum foil of length 14 cm and width 12 cm. Due to high electronic voltage, the use of electronic devices during the process is prohibited, so we cannot show the whole process. After running a complete batch of 2 ml polymeric solution for 3 hours, we will get this kind of results, and after drying the nanofibers matte, we can use it for further evaluation. That's all from my side.
Thank you.